You ready? I'll go ahead and get started. Emily, you ready?
Yeah, we're all ready. Thanks.
Right. Okay. All right. Well, welcome everyone to today's webinar. My name is Sarah Carr, and I'm coordinator of the Coastal Marine Ecosystem-Based Management Tools Network, the EBM Tools Network for short. The EBM Tools Network is co-coordinated by Octo and NatureServe. And I also wanted to welcome our other hosts for today's webinar, which is the Lenfest Ocean Program. We're very excited to have Beth Fulton of CSIRO and Keith Sainsbury of the University of Tasmania on to present on building knowledge, capacity, and collaborations to develop indicators for ecosystem-based fisheries management. So to give everyone just an overview of how things are going to work, Beth and Keith are going to be presenting for about 30 to 40 minutes, and then we'll have time for questions. We highly encourage you to think of your questions and send them in throughout the webinar just as you think of them. If there's quick clarifying questions, we may ask it during the webinar, but otherwise we'll hold all substantive questions till the end, to the Q&A period. So, and you can send those questions via the chat panel or the Q&A. And I will now turn it over to Emily Knight from the Lynnfest Ocean Program to introduce the research.
Great, thanks Sarah, and welcome everybody. We're so excited to be co-hosting this webinar along with Sarah and the EBM Tools Network and Octo. My name is Emily Knight. I'm a manager with the Lenfest Ocean Program. For those of you who do not know us, the Lenfest Ocean Program is a grant-making program that funds research projects and expert working groups to address priority science needs facing ocean and coastal decision makers. And to learn more about us, you can visit us at lenfestocean.org, where you can also sign up for our newsletter and follow us on Twitter at lenfestocean. So the project you're going to hear about today was funded by Lenfest and has been ongoing for the last couple of years. And what's really special to us about this project is, first of all, it's addressing a very important science need for indicators of ecosystem structure and function. But it's not just the science that Beth and Keith and their partners are doing, it's how they're doing it. Which is by collaborating with managers, policymakers, and other scientists from all over the world to ensure the indicators are usable and can apply across many different ecosystems and management contexts. So for us, this project is both about putting in place the scientific building blocks for ecosystem approaches to fisheries management, as well as linking science to management and policy and spurring new partnerships and dialogue along the way. So the last thing I will mention is that if you'd like to connect about this project or receive updates, my email is at the bottom of the slide. Please do reach out. It is our intent, along with Beth and Keith, to share progress, take input, and connect with folks as interested. So don't hesitate to reach out. And that is all I will say. So I will turn it back to you, Sarah, to get going with the presentation, and I will stop sharing now.
Okay, great. And I'll just go ahead and turn it over to Beth. And Beth, you are just to remind you, you are muted.
Hey guys. So thanks for that great start to the explanation of the working group. So the working group involves not just myself and Keith, but a large number of people from around the world. This is an update of where we are, about a year away from the end process. So just remember, all of this is still a work in progress. And if you want to get involved, I'd reinforce that you just contact us and we can see what we can work out. So if we look at what people want from ecosystem-based management on the international stage, the laws and the documents in place do stress the desire for preservation or conservation of the ecosystem structure and function. But there's also that social aspect. It has to be a social choice of what it looks like. So ecosystem-based management isn't necessarily going to look the same place to place. Each country will have its own priority and whether they emphasize the ecological, social, or economic end of things. So right from a very conservation-oriented approach through to being primarily focused on food security. So is there a way of having a set of tools? What kind of tools would be able to support ecosystem-based management? across all of those different contexts. That's the background that we're coming from. So if we look at the operational side, it's largely in the nation's legislation to be focused on maximum sustainable yield, but we know that doesn't work. For places where you've got many different fisheries very cleanly targeting individual single species, it could in theory work, but the reality of the world isn't like that. The fisheries of the world are either mixed fisheries where you're catching multiple species with the one gear. Now if those species don't eat each other, if there's no trophic interactions, then you're still not going to be able to achieve maximum sustainable yield of all of those species simultaneously. Even when there's only those technical interactions, you'll have some species that are limiting. When you get to multi-species fisheries, such as the ones across the tropics and in the big trawl fisheries in the temperate world, it's even more complicated because of the trophic and technical interactions. So that's the target. That's the one we really want to nail because they're the ones where the big challenges are, but also the biggest needs around ecosystem-based fisheries management. So the personal motivation of Keith and I to get into this is because over the last 30 years, there's been many observations that those multi-species fisheries have a very different shape to the curve. They have this big flat top before a sudden drop off rather than the peak that we see in classical fisheries texts. So about 20, 30 years ago, that was assumed to be a result of many of these big flat top ones being from tropical systems and these ones being from temperate systems. About 5 years ago, I was involved in some work that started to explore the status of the world's fisheries. And in that, we again observed this particular pattern. So just as an ecologist and mathematician, I wanted to go away and understand what that pattern was about. So I fished those model ecosystems from a range of different types, from polar through temperate to tropical. And I expected to see this shape, these two shapes, and to then dig into why they were there. And to my surprise, what I found was the shape came from the way that we fished the system, not the ecosystem itself. So if you fish in a big multi-species effort where you take lots of different species at the same time, you get this flat curve. But if you go very selectively and you target specific species with priority, then you get this shape. So it was the way that we tackled the system that was the defining force. And that's important because you see very different patterns of species extirpation out of those different patterns. So if you target very specifically, first you actually see a faster rate, at least in the model world, of the drop-off in species, where it's a slower, flatter one in the broader, taking all of the different species. Now, these aren't excuses to go hell for leather and fish as much of an ecosystem without any control as you possibly can. That's never going to be a successful outcome. You will crash the ecosystem and cause a lot of pain and desperation. But we do need to understand the implications of how we fish an ecosystem. So the way that it goes is that if you look at the food web structure, what's happening is that the learning from network theory, from pure mathematics and from other fields, you can analyze the flow of production through an ecosystem and understand its connections. And that explains the patterns we see here. So ecosystems have evolved to be incredibly efficient at delivering food production, so primary production up through the food web and to disperse it through the food web. So they have a high information flow content in mathematical parlance. That also, the structure of ecosystems makes them very robust to the random deletion of species. So losing species at random isn't something that will completely destroy an ecosystem. However, many ecosystems actually have what's known as a hub. It's a bit like the keystone species idea. It's about the ones that have this disproportionate role in the system. But in this case, it's not about necessarily eco-engineering a system being a structuring force. It's about being how it connects the interactions together. And when you selectively fish an ecosystem, you can unintentionally destroy one of those hubs and effectively shatter the structure and function of the ecosystem. And so that's been our motivation for trying to understand how can we give advice on that risk to structure and function, because that was the biggest gap we could find in all of the work that had previously been done. It had been done about status of ecosystem or trends in ecosystem components, but not about that true structure and function and the implications of that for fisheries. So with that knowledge in hand, the idea was to see if we can capture with a set of indicators that understanding of structure and function, and then use that to inform standard fisheries management, or to find new ways of having multi-species fisheries management that's more informed about the true structure and function of the ecosystem. Now, the concept that we're building this into is, I have a farming background. I grew up on a farm, and on those farms they had these big old tractors with lots of handles. So if you've ever seen pictures of driving a crane or an ancient tractor, they have lots of different handles that you need to set in different positions to steer that piece of equipment around. It's exactly the same kind of concept we're trying to use for ecosystems. So if you imagine each one of those handles being a different gear type, trawl, gill net, hook and line, purse seine, all those different kind of things, each one of those interacts with the ecosystem in a different way. So you can use it like a lever to steer the ecosystem, or steer our footprint in the ecosystem to the desirable extent possible. So how do we get an information source that can help us understand how to do that kind of steering? So the concept is that a lot of what we've heard about in the past is about the total footprint of fisheries, without necessarily unpacking how those different, how the different gear types actually play out through time, and implications for that for the total footprint of the fishery. So one of the first tools we developed was actually just a little bit of an exploration tool. So this one is still being a little bit polished, but it does capture the basic concept. So as you fish across, increase the intensity of pressure across an ecosystem, you actually see different species fall out at different times of when they peak. And that's a pretty classic idea that's fairly well understood in fisheries, but the pattern and the shape of those curves are actually dictated by the combination of fishing fleets. So in this particular example, we've got a trawl fleet, and it ends up in this combination of species and evolution through time. This one here is a bit more purse seine oriented, and you can see it has a different outcome, a different shape. So the idea is just to create almost it's a toy, effectively, to play with, to understand the implications of, if I move my set of gears in this way, my ecosystem will look like that. If I move my set of gears in a different way, how will that ecosystem look like? It also has a panel. I haven't had the opportunity to put it all here, but it has a panel to show you the indicator of structure and function and how that changes through time as well. So you can start to play with what combinations of fishing fleets do you need to move the ecosystem in the direction that's your objective for your society. So with that kind of concept in mind, that was the basis for the working group's approach. So we had a multi-pronged approach to try and to move this ahead. And this is the initial plan that we set up. It's evolved a little bit through time, but it's still roughly, well, it's still quite close to what we're doing. So the first part was just to do the usual kind of thing, go out and see what everyone had said before. What are the objectives for ecosystem-based fisheries management? Which are the indicators that are already being considered? How effective have they been found to be? And is there any significant gaps in the coverage of those indicators versus the objectives and the performance measures and information that we actually need? The next part is for all of the indicators that have been suggested, to understand when they will and won't work. When are they most effective? When are they least effective? How much information about the ecosystem are they actually conveying for us? We want to do that with a set of simple models. So a minimum realistic approach, or the models of intermediate complexity, MICE models, you might have heard of them. So the idea is to have just enough of the detail of how the ecosystem works without requiring many years and enormous amounts of data to construct, so that these tools are also useful in different locations with different availability of data, as effectively as a little bit like assessment models to help understand what's happening in those ecosystems. We will double check them with much more complicated, very finely detailed, well fit to historical data models as well. But we realise that kind of model is pretty specific and a large resource. So it's not something that you're going to be able to use as readily as the simple models. And the way to use the models is that you have your model set up and all calibrated, then you feed it with the different scenarios that you want to think about. So that might be different levels of fishing, it might be different other things going on in the ecosystem, such as climate. From that model, you actually generate simulated data as if you'd gone and collected data in the real world, but you just collected in the model instead. From those, you calculate the indicators exactly the same way as you would in the real world. And then you compare them with what the model's exact trajectory was to see how well the indicators reflect that trajectory. How much information content do they really have? And that way you can evaluate the performance of the indicator so you can understand how well it conveys information about the system, how uncertain it is, whether it's got biases, even if it's inversely related. Is it giving you an up when the model's doing a down? Just trying to understand all of those different nuances. Once we have that understanding and that suite of indicators, which we've partially done, we're a long way down that process, but we're not quite there yet. Then the idea is to go out to the different partners in the project and have them basically calculate the indicators on real world data sets. So the kind of information that's already available and already being collected, so that there's not a huge requirement for additional data collection. We're all very aware how much budgets around the world are trimming down, that there's a lot of competing demands on people's data and on the money. So we didn't want to have something where you suddenly had to collect lots more information. How useful are those indicators in those contexts? And on the back of that, we aim to write a guide on how to implement the indicators to provide that ecosystem information into management, so you do have a form of ecosystem-based management, or at least an ecosystem approach to management. So the formal partners, when we set out to do this, we wanted to find systems of different ecosystem type. That was number one. So you can see here that we've got a temperate system, a subarctic, so a subpolar system, a big upwelling system, and a very typical tropical, highly diverse system. So that was the first context. The other context is we wanted it to be from different cultures, from different nations with different objectives of what they wanted out of their fisheries management, and indeed different management systems themselves, to really do that check about how robust this method was. There was no point us spending 3 years to find something that worked wonderfully in Australia but couldn't be transported to anywhere else in the world. There's a long history in fisheries of the North Atlantic science done for North Atlantic having to be used elsewhere in the world, and often suboptimally. So we wanted to find something that was truly robust across all those different system types. Now, it's a measure of how interested and how timely this piece of work is, that we've had quite a large number of groups come to us and say, actually, we're really interested in what you're doing. Can we informally link up? And that's done to differing degrees. They don't come to our formal meetings, but they do share the information. We are trialling the indicators in those locations as well. We're teaching some of the methods. So in places like Thailand and Vietnam, we're helping them understand how to do the methods, how to do the calculations, and have that capacity building as well. In other locations, it's literally just around the indicators. But there is that worldwide interest now in how you really do ecosystem-based management. One of the key approaches that was important to us was to have that link between the scientists, the managers, and the policymakers. You very often see in fisheries or any resource management that you either have a science push upwards, where they've found something they think people need to know about, or they've found a method and then they try to push that back through the management system to policy. That's a very hard process to do successfully. Equally, there's often cases where the policymakers have a need and they come to the scientists, but the science isn't ready yet. There's a scrabbling to make sure you connect and the opportunity can be lost. We actually wanted to go the route of co-production, where you're all in the room together, so that you can make sure that any of the science recommendations actually are sensible in the context of the real world constraints of the managers and the policymakers. Now, initially, we thought we would do that by having that management advisory committee on that original slide that I put up. The intent was to have the science, and then on the very back of our 6 monthly science meetings, to have the policy and managers review what we've done and say, well, look, no, you've gone a little bit wrong here, it's not going to work for this reason, in this context, or this policy requirement. Logistics meant that in our very first meeting, we each sat through the whole thing. So the managers and policymakers sat through the science meeting, and the scientists sat through the connection of policymakers and managers. And we got so much out of that the general consensus was that we needed to run every meeting like that. So everybody, policymakers, managers and scientists, had to all be there for the 4 days every single time. And that's worked really well because it's allowing connections that don't normally happen, both in terms of discussions that you can't have in the day-to-day between the scientists and the policymakers, because there's not the space in the normal council process or the normal management decision-making process for the kind of conversations you can have in this context. But it's also because the policymakers and managers very rarely get the opportunity to connect across nations. So scientists go to conventions and conferences to discuss the latest science news, and they share papers and they have their own network, but it's much, much harder for managers and policymakers to connect across nations to see what are the hurdles, what's worked where, what advice can they bring along, what was meant by a particular decision. And so to create that connection has also been of immense benefit to the people involved. So what's come out of that process so far is that an approach to pragmatic ecosystem-based fisheries management, or an ecosystem approach to fisheries. So the first one is around having very useful multi-species models so that you can understand the dynamics, and they have to include trophic as well as technical interactions. They will have a potential assessment role going forward, not in a typical quota setting role necessarily, but it's more that understanding and that frequent update potential of what's the ecosystem doing, how's it tracking. There's also the indicators side, and it's not just about ecological indicators, it's also about the human dimensions, because it was fairly quickly appreciated that unless you have that context to what's going on in the ecological side, you actually have an incomplete picture of the ecosystem as a whole. Lastly, there were dedicated effort to find indicators of structure and function, because that is a gaping hole in the current indicators work. So if we look at the models first, the different kind of model types we have quite a toolbox of approaches. We're actually putting less stress on species distribution models, and most of it has been on highly interactive dynamic models with connections. So the simplest sort of ones are the multi-species production models, where you have ecological and technical interactions. There's the size-based modelling that's increasingly popular and effective around the world. There's the minimum realistic approach, where you have the either dominant species or indicator representative species of the different kinds of classes of species in the system, whether they're habitat formers, forage fish, vulnerable species, the main target species, large marine mammals. So you have a selection of key species that represent the broader system type, and you play out their trophic interactions and their habitat use and their food layer. And then we've got EcoPath with EcoSim, which is now widely used around the world. It's fairly robust piece of software that's got a lot of support, so it made sense to include it in the mix, particularly given the capacity to have that real ability to dig into the food web and network structure by taking that approach. On the review side, with the number of indicators, if we look at the human dimensions first, Ingrid Van Putten and Sarah Hornberg led this work. They reviewed quite a few hundred papers and whittled it down to 134 relevant papers, mostly from North America, Europe and Australia. Admittedly, they couldn't find in the broader literature examples from other continents. They might be there in other languages, but given the suite of languages available to us, these were the only ones that could be found. What they found out of those 134 papers were 57 indicators of different aspects of the human dimensions, as well as 60 objectives that had been defined for fisheries and fishing communities. Interestingly enough, though, there were only 2 papers that took the effort to link objectives and indicators. So that's a gaping need to actually have that linkage, because without it, you can't create a performance measure of how your management and your ecosystem evolution is actually meeting your objective. Of the indicators they did look at, there was 181 indicators. So the 57 indicator papers, and 181 indicators considered. So of those, the majority were actually around the social side, or the largest number around the social side of fisheries, particularly considering community wellbeing, safety and equity. There was a longer number, but that was a particular focus of the social indicators. The next largest chunk were the economic indicators, largely focusing on profitability of fisheries, though again there were some other economic indicators listed in that group. And then the last chunk were the institutional indicators, looking primarily at compliance capacity and the monitoring system, where the biggest hole was around governance indicators and what that tells us about the integrity and inherent nature of the management itself. So that's an area of interest to a couple of the researchers in the working group. So there's now active effort to try and find informative governance indicators to build into this bigger picture across the ecological, the social and economic aspects of the ecosystem, and to actually find what's realistically feasible to track through time. So ironically, it's turning out that it might be easier to do some of the ecological indicators than the social and economic ones, but we might also need to diversify the data streams that we pull on to get that broader information. On the ecological indicators side, there's been nearly 20 years of work now across the world in this area, so it's a highly productive, enormous literature. So we're not trying to say we started from scratch. We're certainly building off the work of those who've gone before, such as Indices and the ICES working group on the ecosystem effects of fishing. We did go through indicator lists that had already been put forward by groups who have that ecosystem perspective to see how generalizable they were. In the end, we classified over 400 indicators, and Jacob Rogers and Camilla Novaglio led this work. So what they largely did was to classify the indicators based on the status and trend, whether they're just informing on the components of the ecosystem and what's happening to them, whether they really are giving you a sense of what the structure is, so the network connections and the relative abundance, or whether they're informing on the functions, so the flows and rates and that kind of thing. And then what was the level of aggregation? Are they being reported at a population level, at a functional group or community level, at an entire ecosystem level, or what, are they physical and chemical? Are they giving you a context for what's happening in that broader ecosystem? So you can take those 400 indicators and they roughly fall into these different groups. So the types listed down here. The ones in orange are the ones that have had the most attention or have been found to be the most effective around the world so far. But you'll notice that there's actually a bit of a gap around the trophic and the network. In fact, around the structure and function in particular, there is still a bit of a gap. And so that's where my own work feeds in. I've been looking a lot into the structure and function side of things and what kind of available data can tell us about that. So one of the most commonly available data is catch data. So that's a very contentious area. Some people love it, some people hate it, but the reality is it is the most commonly collected data. So can it have some information about the ecosystem in it, particularly from these multi-species fisheries, regardless of whether it's telling us about a trustworthy measure of abundance? Can it tell us anything about the composition and connections in the system? So these are two examples from different case studies. So they have a time series from 1950 in India. So if you look at the composition of the fisheries in India, the catch over that period of time, you can see that there appears to be a regime change, at least in what they're catching, if not the ecosystem itself. Now, talking to experts in the system, there did appear to be a large-scale shift both in the fishery itself, but that was in response to a collapse of the oil sardine and a shift to more offshore waters. So it is telling you a story about the pressure that's happening in that system, how it's diversified, how the species being caught and indeed the ecosystem itself is shifting through time in India. In Australia, there's a little bit of a different story. It seems to be capturing the recovery in both species composition, but also the underlying ecosystem in Australia, given the efforts in fisheries management over the last 10 years. It's been interesting to try and unpack this evolution and how much of that was influenced by fisheries versus climate, but it does also seem to be capturing this recovery. So that suggests that in these multi-species fisheries, where you've got these large-scale gear controls, but you're still sampling an entire ecosystem, that there could be some structure and function content in that catch data. So that means that it looks like you can start to tease out whether there's thresholds in either the fisheries footprint on the ecosystem or in the ecosystem structure and function itself. So what society decides is desirable and undesirable, we're not going to comment on. What we're trying to find is, can we find information sources such as the catch composition and indicators you can build off that and other information that lets you understand where those thresholds are, and then to be able to build in a precautionary buffer so that you can actually have well-informed management that keeps you away from undesirable states. And that's where we get back to the network work that I've been doing. It does appear that if you bring in ideas from engineering and neurology, so there's a lot of different applications of network theory in the world, from the way our electricity grids go, the way our traffic runs around streets, or indeed rail networks, airline flows, the functioning of the human brain, the circulatory system. There's an enormous number of different sciences that rely on network understanding. The internet is another great example. There's been a huge proliferation of indices around understanding networks since the internet took off. And that means you can leverage off that and bring it back into ecology and add to the network-based food web work that's already happened to find these indicators. And it's come down to understanding what happens when you take those key hubs, those critical connections out of the system. And that's where you can start to understand the structure and function, but you can also begin to understand how the network warps as you put either equal pressure across the lot or put uneven pressure across different parts of the ecosystem. And that's the next step beyond that was some stuff that's definitely right at the bleeding edge of the work I'm doing at the present moment. So these next couple of slides are definitely a work in process. So taking that topology understanding from the network and marrying that in particular with a method of saying you do a sort of a biomass production profile in an unfished system. You compare that to the catch production profile in the fish system, and you can get an idea of the distortive pressure being put on that topology. Now, by itself, that can give you a long way to having an index of how much stress the ecosystem is under, but you can also marry it with some other advances that are coming out of network theory around structural resilience of networks and the ratio of flows to abundance or size of the node. You can also use a random graph method, exponential random graph, to look at what are the key processes that are actually occurring in that ecosystem and are they changing through time. So you can bring that together to give you basically a relative score of how much stress is the ecosystem under and how resilient is it to that stress. So the way to think of it is you can unpack it at that level. You can have the very clear pieces of information so you can see what's led to the outcome, or you can have it at the overall score level, a bit like a cyclone rating or a fire danger warning rating in Australia, so that you can have it unpacked, or you can just have it at that warning scale. So this here is a example of what we're currently doing. A lot of the examples are actually from 1990s to early 2000s data, so I wouldn't put a lot of immediate gasps if your particular system is yellow or orange right here, right now. It is a work in progress. The idea is to test the indicators in model world, to look at them, how do they differ across systems that are being fished in different ways? How well do they reflect that structure and function of the ecosystem, at least as captured in a model? And how does the indicator change through time as the pressure changes? So, for example, in Australia, through the early 70s and 80s, we started to build up pressure. In the 90s to early 2000s, we'd started to really stress our ecosystems. But the more recent work suggests that we've actually started to recover that ecosystem back to a fairly healthy structure and functional state. Whereas the combination of exploitation and climate in particular has started to stress the Great Barrier Reef. A different example is from the Gulf of Thailand, where even back in the 70s, they'd put a lot of stress on that ecosystem. By the 90s to early 2000s, it was on the verge of collapse, according to this index. But the major management reforms that have come in over the last few years seems to have turned that around. And there's observational evidence of this from surveys in the Gulf of Thailand, but actually the model suggested as well that that system is beginning to recover. It's by no means completely out of the woods yet, but it's certainly turned it around. In contrast, the immense changes that have happened in Myanmar through time suggest that it's one of the few ecosystems in the world that a whole ecosystem will be on the verge. A pretty daunting thing to have come across some of it. It's different elsewhere in the world. Like I said, it's still evolving, and particularly we'll be interested to see how this is captured by time series from those individual locations. So this will be something to check with us as we go forward, particularly in about a year's time, and work sort of finished up.
Beth,
so if we look at the
I did a question. Are the gray circles, are they indicate that you're working on them? Are you've attempted them but there's insufficient data, or what do those indicate?
Sarah, are you able to see the webinar?
No, I think we've lost Beth. It was getting a little wonky there, and she's gone entirely. Keith, do you by any chance have the rest of the presentation handy?
No, I don't. I'm sorry. Beth finalized that.
Okay.
Yeah, sorry.
Okay. Well, I'm sorry, everyone. Well, we can give it a few minutes and see if Beth is able to join in. You could tell the connection was getting a little wonky for a while, so let's see. We'll give it a few minutes. We did have a couple questions. I don't know if you could answer in the meantime, Keith. Were you able to hear my question about the gray bubbles? Someone else also asked that.
So those looking back at that, trying to remember back to that graphic, they were areas where we're actually engaged with people from those particular ecosystems, but they're not fully involved with the study. So what we're doing in the 4 primary areas is we're making sure that we can do all 4 types of ecosystem model in all 4 of those systems. In the other areas, we've got partial information. We're relying on the folks who are doing the work in those areas to come forward with the kinds of models that they're using. So for those areas, we've got a bit of a smorgasbord, if you like, of different modeling types being used in each of those places. And so we're trying to use that to fill in some additional information and understanding. But it's the 4 primary ones is where we're making sure that we've got all 4 of the ecosystem types, ecosystem model types being used consistently in each of those 4 areas.
Okay, gotcha. Beth, sorry, we lost you. Can you go back a slide, and I'll tell you where we lost you.
Okay. Yep, there we are. Is that where we were?
Yes, and I had just asked what the gray bubbles meant, and then Keith explained to us what that was.
Yeah. So sorry about that. For some reason, my office suddenly decided I wasn't involved in the network. So I'll go back this way. Yeah, so the grey ones are this is all about different tests. So it's all based on ecosystem models at the present moment. Whether we can capture in this indicator, whether you get the correct differential in space, but also that change through time. So in places like Myanmar, there's a lot more pressure than on, say, New Zealand. And places like Thailand, you've seen that pressure grow up, and then it's under the changes of the last few years, it's turned around. So can we capture that kind of pressure? So this is all a work in progress. I wouldn't put a lot of stock in the different pictures now. We're still figuring out the details, but it'll definitely come back a bit more in about a year's time.
So Beth, Beth, just on that, while you're offline, what I said there was that the grey patches there are places where you're still yet to see whether the modelling that's available there can be properly fitted into this scheme.
Yes. Yeah, exactly.
Yep.
So in terms of the process that we've got up to within the working groups themselves, we've put a lot of effort into building the capacity in the different locations to make sure the tools really can be used in those locations, effectively developing little course on how to do multi-species modelling and how to calculate the indicators. We are developing an R package so that these indicators can be readily calculated without needing to go through some pretty hairy mathematics yourself. In the terms of the progress in the different locations, the US was already a long way down this track. And they're sort of just at the testing stage. They're putting a lot of effort into understanding the indicators, the governance indicators. In terms of Chile, they're still getting their models sorted. They've got a large amount of data available, and we're sort of moving the modelling and the data together in combination. In Australia, we've been finalising our own models, making sure we've got that complete tool set ready and helping write the packages and figure out which are the indicators, and we've started the testing process here, mainly because we can work quite closely with the people we need to check details and that kind of stuff. In India, they've got their modelling under control. They're very well into the calibration side. They've collected and collated an enormous amount of data that's been collected historically and keeps going in India. So we're at slightly different places in the different parts of the world, but we're all pushing to meet a particular deadline, which I'll show you at the end of the talk. We are progressed enough now, though. We've learnt some lessons already around what are barriers to ecosystem-based management and what are some of the lessons that we can already extract. And people often say that, or I've heard it said quite often in the literature and at meetings, that it's political will. People aren't ready for the change. They don't want the change. We've actually found that's not the case, that wherever we've gone to talk about this, that the policymakers and managers really want to make a change. They just don't know how to get there, how to do it. So allowing them to connect both with scientists but with each other has helped them understand that route and what are the pitfalls and what are dead ends to avoid and what needs to be context specific and what's more general. The other thing is we often hear is that there's not enough data. We need more data. As a modeler, I'm never going to say don't get data. It's a wonderful thing to have, but there's actually an enormous amount of information out there. A lot of the developing economies have either their own data collection systems. There's trawls in many of the tropical nations of the world that you might have been surprised by. But there's also the Nansen series that snapshots different. It's only a snapshot here and there, but it's often enough to piece together what's happening. So it's about digging that data out and making good use of it, because it's often hidden away in someone's cupboard, or it's held by one institute and not used by another institute. So it's making better use of the data that we actually have, and we can already get pretty clear idea of what ecosystems are doing. So the lessons we've had so far is that co-production and co-learning is really, really valuable, right down to taking the time to sit through the science and the policy and management discussions that you wouldn't normally be privy to, because it allows for conversations that are beyond the bounds of what's possible in our normal day-to-day work. In addition, we all have very similar concerns about what we're facing with ecosystem-based management and indeed the future of our ecosystems. So in our first meeting, we went away to think about scenarios that we'd want to explore in the different systems. What were the big pressing management questions? And we each went off into our little country-based corner, and when we came back to plenary to have the discussion, we used slightly different words, but we actually all had the same general concerns. We were all concerned about what the climate was going to do to our ecosystems and our fisheries. We all had a question about what's the implication of having an unconstrained sector. So that might be recreational fishing in Australia that's not under as strong control as commercial fishing. In other locations of the world, it might have been a traditional sector or a different sector that you can't bring as much management stricture over. And then the last concern was about what happens if there's one particular gear that's off the table. Should there be some gears that just not allowed to be used at all in fisheries because of their influence in structure and function? Or are there some gears that for social reasons we can't use, which means that we don't have that full set of levers to steer the ecosystem in the way that we'd like? So that was basically how it came out. We all had exactly the same interests, in effect, about despite our very different backgrounds, about what the ecosystems are doing. And lastly is that we came to the conclusion that to get fairly pedantic about the definition of ecosystem-based versus ecosystem approach, we are all effectively doing an ecosystem approach to fisheries management. We haven't tried to reboot the governance system to take a very different look. We're all of us bolting ecosystem thinking into structures that were originally defined based on single species definitions, single species management concepts. So we're taking an ecosystem approach, but we're not really doing ecosystem-based management. And it may well be that we never need to take that governance reboot, or that it would be too complicated to deliver. That we can really find these indicators and processes to piggyback on that single species institutions to actually get ecosystem outcomes, which was reassuring for many of us that there wasn't this huge insurmountable hurdle to transition from what we were currently doing to what was seen to be done in sort of the gold standard locations that have been pursuing integrated assessments in something for a long time. It was effectively an evolution. It wasn't a revolution in what we had to do, which made particularly the managers and the policymakers a lot more confident that they could do it regardless of the system that they were in. So far we've looked at that big global picture, and we've found that ecosystem structure and function is key to that. But it's also the gap that we have in the science. We haven't been tracking that. We've been tracking individual components and had a lot of attention put to, say, abundance and trajectories rather than that structure and function. We've also been thinking about how to bring indicators into the idea of how you steer a whole ecosystem rather than being concerned about a species at a time. We've been able to explore the options that are robust to context because of that broad scale collaboration. It's been a really rich endeavour. We are still at the level of field testing things. More results will flow over the next year with the project, the working group I should say rather, to roll up by mid-2020 is the current aim, or the current deadline, or ultimately the deadline I should say. But the most important thing has been that joint learning, that we're actually all in the same boat. We have the same interests, we have the same challenges, so that there isn't this dichotomy between nations that have more dollars available for surveys and the so-called data rich compared to those that are struggling with thousands of species. We're actually all in the same boat, so there's a lot of lessons that we can share together. So if we look at the next steps for the projects, in the next couple of months, we're going to have all the models finalised and calibrated so that we can take them into the actual indicator testing. So the index I showed you with the map, the testing of that is hoped to be complete by the end of August, at least in the model world, and then we'll fold it in with some of those structure, some of the existing indicators that have been found for the human dimensions and the status and trends indicators to test that whole suite to tell us if we can get a complete ecosystem picture, at least from the model world, by the end of this calendar year, the start of next year. And then by the end of the first quarter of next year is to actually have the trial runs on the real world data complete so we can see what hiccups that arise and what modifications are required. There's a little bit of that going ahead of time so that we can understand if we've got any remaining huge goals, what are the huge hurdles that we're not going to be able to get around with this approach, in case there's extra new things we need to think about. And then all the way through that process, but particularly towards the end when we've got some really tangible outcomes, we're going to communicate outcomes and results to the broader audience. And that's it. So this is the group that's involved. Across the top there, you can hopefully see the connection to the website. But yes, we're very happy to stay connected with anyone who's interested in this outcome. I think it's something that is of general interest around the world right now, and the more brains on it, the better. And so that's it from me.
Fabulous. Thank you, Beth. Keith, I'm going to unmute you too so you can participate in the question answering. And thank you, everybody. And I see, I was just going to encourage you to send in questions, but I see several of you have already taken advantage of that. But again, you can send in questions through the chat or the Q&A. So we'll dive into the questions now. There was a question, is how will this index be different from something like the Ocean Health Index?
So the Ocean Health Index brings together the stress side of things. This index is trying to actually reflect the internal structure and function of the ecosystem. So you could probably use the two together. I haven't actually explored that as yet, but it's trying to come from the internal side to fill the gap that hasn't been covered before. So it's not just about the risks to the system, how much level of pressure is the system seeing, how much change has already happened. It's actually telling you about the internal integrity of the ecosystem and trying to use that in a way that you can then bound what's reasonable for different species to be at. So when you have a fish system, you're going to have some that are around the classic single species target levels of 40 to 50% of an unfished level. Then you'll have some that are just more vulnerable and will be at lower levels, though hopefully not to the level of extirpation. Then you'll have some more robust species. So understanding that mix and whether your internal structure has that mix about right, or whether you've put too much pressure and they're all sliding towards being overly exploited, or whether you've got extra scope still to expand at the other end. It's about giving you that internal structure, not just the outside pressure.
Okay, great. Thank you, Beth.
So I might just add a quick comment there. This still needs some testing, as Beth was saying, but it's basically a combination of production and food web topology. That's what this indicator is that we're looking into.
Okay, thank you, Keith. Let's see, and there's a question, are the project methods applicable to artisanal fisheries? And this is someone who's been working in the north and northeastern coast of Brazil.
Yes, so the whole idea is to make sure that they work everywhere, and there's indeed artisanal fisheries within the Indian example. So the intention is that it should work regardless. So regardless of what kind of fishery you're in, you're humans using a gear to interact with the natural ecosystem. And that's the premise that we've started from, that if all fisheries are generalizable in those terms. So taking that mindset forward, you can use this approach, both the talking with people, co-production side, bringing the data together side, because there's lots of different sources of information, even if it's just information in the head of the fishermen themselves that you can extract with some fuzzy logic to correct for biases and that kind of understanding. There's an immense amount of information out there on ecosystems. So how do you bring that together in this useful way is the intent.
Okay. Okay. Great, thank you, Beth. Then I have a question. So there was a question of if you have a couple of recommendations about for how to integrate local community stakeholders into the co-production of knowledge loop, the scientists, policymakers, managers, co-learning. What would those recommendations be?
Do you want to tackle that one, Ken?
Well, we're not trying to redesign anybody's management system for them, but one of the things that this project is really very strong on is that policy management science connection needs to be made. So that does need to be there. The 4 case studies that we've gone into, which we chose them to be reflective, as Beth mentioned, of some quite different local systems. As we've come to understand those arrangements better, and particularly, I suppose I should focus on the Indian and the Chilean one, those mechanisms are there in those management systems already. Now, in some cases, there may be some advantages in having them particular mechanisms made more strongly, but so far we've been really pleasantly surprised that we can work with any of the existing management systems and get through to both the stakeholders and the information that we need to be able to do the modelling and calculate these indicators. So that's quite an encouraging thing. It's not to say that that necessarily is true everywhere, but I think what we're trying to show here is that with those connections being made, even where you've got those small scale or indigenous artisanal fisheries, we can still make progress here.
So the additional part is that in these particular cases, it did turn out that community members were already feeding through that system. It would obviously need to be applied in anger, so to speak, to actually say in a system where those community members aren't already in the loop, how to pull them in. But given the way that there's 4 different ways effectively, each of the different locations pulls those community members in a different way. So there's at least 4 examples of how to do it. You could literally have them at the table too, or representative people at the table. There's quite a lot of work now in the transdisciplinary science world of how you get community members at that broader conversational table. So I won't try and summarise all of that here, but precedents basically do exist. And if you want to have a longer discussion offline about that, I'm happy to do it. So because there's literally a vast array of ways of doing it, depending on what other routes they have to get their voice heard at the table.
Actually, the other thing too, just to mention that, I mean, there are 2 different aspects of this question, perhaps in a way. One is actually getting the engagement and information and understanding into the overall, assessment and management decision process. But then the second part is, well, what do you do by way of managing all these different sectors? And the direction we're going in here is we're looking very strongly at some of the primary management tools being available, being the amount of fishing effort or catch that comes through different gear types, because that's what fundamentally drives the selectivity on the ecosystem. Beth mentioned that basically all 4 of our case studies raised, and without our pushing, just raised themselves, that they've all got sectors that currently they don't really have good management control over. So maybe that's another aspect of the question that's being asked. One is how to make sure that all of these sectors have a seat somewhere, get their information and their issues in. But then the other side of that coin is how do you control all sectors if in fact you are going to be using as one of your primary fishery controls, how much catch and effort goes through different gear types. Yeah? And we've got at least some sectors and gear types being poorly controllable in all of our 4 case studies.
Okay, thank you guys. A couple other short questions, which I think we can get to. I don't know if they're short actually. How would you use the index if the region or country doesn't have EBM objectives?
You go. Where we're starting with that, and that's why Beth showed those slides in the outset. Even if countries don't have specific EBM objectives inside their own fisheries legislation or what have you, most countries, and all the countries we're dealing with here, and all the countries that we've had in our other examples, not just the 4 case studies, they are parties to some of these international agreements like the CBD, like the Law of the Sea, etc., and they do have high level objectives relating to protecting ecosystems and things like that. So we're actually trying to make sure that we've in constructing what our approach is here, we are helping to enable those things. So even if they haven't been turned into specific fisheries objectives in each national context, we're working with that broader context.
Did you have anything you wanted to add, Beth? Thank you, Keith.
Yeah, so some of the fundamentals of the index will hold regardless. Even if you only had single species management, you want to have the system to deliver to that. So on that side, you can still consider the topology and the relative production coming out of the system. So the index will work regardless of what your objectives are. It's just more meaningfully connected back to performance measures.
Okay. All right, thank you. Another question. This is a quick one. Has the work on the indicators of the human dimensions been published? Is that available for anyone to look at?
I think it's in the very final it's certainly gone through review. My understanding it's accepted and in press process. But if you're interested in that, either just email me and I can connect you with Ingrid to chase up where it's at.
Okay, and Colette, if you need that connection, if you don't have or can't find Beth's contact, you can contact me, Sarah Carr, because the emails come from me from the webinar. So anyway, we can make that link. Let's see, and a final question. Could you elaborate more on the precautionary buffer on the regime shift graph?
So it's the basic idea that if you're driving towards a cliff, you want to stop well short of the cliff. So you don't want to actually try and do like a movie style end right at the cliff. You want to stop well back, particularly if you're a driver like me. So it's about understanding where that cliff edge is and then putting a space there so that you've got enough time to realise that you're approaching the edge and turn away from it, instead of ending right on the precipice because of uncertainty. The way that complex systems work is that they flicker around that buffer as they approach it. So you can end up in the undesirable state, at least even for short periods of time before you completely cross it. So you want to stay well clear of that so you're not putting yourself and the whole ecosystem in either a socially, economically or ecologically undesirable position because you've got too close.
Okay, thank you, Beth, and thank you both to you and Keith. And we've gotten some great comments. Though wonderful presentation. Looking forward to seeing the final outcomes from attendees. So thank you so much for being here today, and thank you for your presentation. And if you need to follow up, I can put you in touch with Beth and Keith if you have additional questions that we weren't able to get to today. But anyway, thank you everyone, and thank you everyone for attending. We look forward to having you on some future webinars. All right, bye everyone.